Well, I'm going to try something else. Hang on. No, that's fine. I'm going to. Okay, so 5.2, number 45, F. And we're going to use the function that they have in D, summation of I equals 1 to N, I 2 over N. There's a bracket around this, and then 2 over N. So, all right, and we just want to show all the F says the limit. F says when the limit find the limit as n hits infinity, and just prove that it equals 4. So they tell us the answer already. So what you have to do first is try to take all the n's out of here. Do you see how this 2n can go in front? All the n's can get out of the summation, and this 2n can get out of the summation also. So 2 times 2 is 4, n times n is n squared. Summation of I equals 1 to n, and then you just have I left over. Are you okay with that?
Yep.
Okay, so then we want to go to 5.2, and this changes to n times n plus 1 over 2. Theorem 5.2, correct? You understand that?
I have it written down.
Yeah, in 5.2, that's what the summation of I changes to n times n plus 1 over 2. And don't forget, we're taking the limit as n approaches infinity. All right, so now we're just going to do some algebra here. 4n times n on top is 4n squared. 4n times 1 is 4n. Something doesn't look right. Let's take a look. And then on the bottom, we have 2n squared. See, something doesn't look right. Did I write it down correctly? Or maybe I wasn't supposed to use D. Wait, show that the limit of S of n, S of n, show that S of n equals this, show that S of n equals S. Oh, I wrote D down wrong. There's a 1 plus in there. I'm sorry. So we got to rewrite this. Let's see. D. Come on. Because it wasn't matching up. So this is what, let me erase this and start over. I might as well just start this all over. 5.2, number 45. And D is the summation of, for I equals 1 to n. But there is a 1 plus 2 over n. 1 plus I 2 over n. I should have wrote this, yes, times 2 over n. All right, so this is what it is. That's D, 1 plus I times 2 over n times 2 over n. Okay, so I'm going to take this 2n out of summation first, and then I'm just left with 1 plus I 2 over n. By the way, we can just, I like writing it better where the I is just right here. So this is what we have here, 1 plus 2i over n. we're going to look at this part first. The summation, when we do the summation of a constant, you see, so we're going to write this in two summations, 2i over n. We're writing it in two summations because of the plus sign. This 2 over n is still part of the problem. We're just going to keep that on the side for now. The summation of a constant from theorem 5.2 is just the constant times n. So this changes to the constant 1 times n. This 2n can pop out of here. You get 2 over n times the summation of I. And then the summation of I changes to from 5.2 n times n plus 1 over 2. So from 5.2, a constant just changes to n times a constant. 2n can go in front, and the summation of I from 5.2, and let me verify that. I know it's that, but I'm going to just verify it. N times n plus 1 over 2, and we still have a 2n here. Okay, so now, why do I still feel something's missing?
Over n.
No, I'm oh, I'm looking at the, okay, which, we're doing 45 or 46?
45.
I changed from 45 to 46 to 45. I had it right the first time. I had it right the first time. I had the answer. Okay, we're gonna try this again. Oh God, I'm sorry, I'm wasting your time. I had it right the first time. I'm switched. See, I'm looking in the book, and I'm jumping between 45 and 46. It's driving me crazy. I'm telling you, when I look at something, it's hard for me to jump from one page. I should have put a little mark in my book with my pen. See, I can even find my pen. All right, once again, I'm gonna hit stop recording.